Hello people, today we are going to work on ray optics. So basically what is ray optics? As the name suggests, ray is a straight line which has a starting point but it has no end. So it terminates here but it has a terminating end, but the other end is non-terminating, it goes on forever. And optics is the branch of physics that deals with light and the things we see, what we see, and how we see them. So, moving on. Light is a form of energy visible to the human eye. We see objects and interpret the world around us, don't we? So, it is an electromagnetic radiation with a wavelength of 4,000 Armstrong to 7,500 Armstrong, which is termed as the visible range. So this is the visible range. We don't see anything which has the wavelength of below 4,000 Armstrong or greater than 7,500 Armstrong. And the path of a light is called a ray of light. And a bundle of rays is called a beam of light. So this one thing is called a ray of light, and this whole thing is called a beam of light. Alright. So a ray of light gives the direction of the propagation of light, and when light meets a surface, a reflection or refraction can happen. Reflection or refraction, these are two different phenomena that happen. As of now we are going to learn only two. In our future videos we'll learn more complex phenomena like diffraction, or whatever. So again, what is reflection? What is reflection? Reflection is basically the bouncing back of light after it hits the surface. So it's like, this is the incident, right? It bounces back after it hits a mirror. So this is reflection. After it meets a smooth, shiny surface, I should say. And then there are substances that reflect light partially. They absorb some of it and then they reflect the remaining part of it. And such surfaces are called smooth surfaces, and such surfaces are rough surfaces, and these do not necessarily reflect light in the same way or in a uniform manner. So but these surfaces reflect light in a uniform manner. All right, so moving on. Reflection, there are two or yeah there are two laws of reflection. Laws of reflection. Ah, all right. Number one, the angle of reflection is always equal to the angle of incidence. So let us say this is a surface, this is a mirror. This, here comes light, and this is the normal. And what is a normal? A normal is a line drawn perpendicular to the surface. Okay, which is normal, and this is perpendicular to the surface. So basically the angle of incidence is the angle between the normal and the incident ray. Alright, and the angle of reflection is the angle between the normal and the reflected ray. So this is So according to the first rule, angle I is equal to angle R. So angle I, that is the angle of incidence, that is the angle made by the reflected incident ray with the normal, is equal to the angle made by the reflected wave with the normal. The second law we are going to learn is that the incident ray, reflected ray, and the normal, the incident ray, the reflected ray. Okay. So basically, the incident ray, for those who haven't understood yet, is the ray of light that is incident or that falls upon the reflecting surface. So this is the incident ray, and the ray of light that is reflected back, or that is, that comes back from the surface. The same ray is called reflected ray. Reflected ray. And here we have our normal, which is perpendicular to the surface. So the second law says that the incident ray, the reflected ray, and the normal lie in the same plane. They are coplanar. They lie in the same plane. This is the plane they lie in, or probably, if not this, you could consider something like this plane. This is a plane, and then these are the three rays we have, but the three of them never lie in different planes. Okay, they are never perpendicular, or they never lie in different planes, is the bottom line. No, this is wrong. So you can say that this is in one plane, this is in another plane, and this is in a third dimension altogether. No, they're always coplanar. Alright, and of course, there's this third law, that the incident ray and the reflected ray lie on two different sides of the normal. They never lie on the same side. So the incident ray is like here, which is on one side of the normal, so the other has to be on the other side of the normal. They are never on the same side. Alright, and now let us move to spherical reflecting surfaces. Alright, so a spherical mirror is the mirror whose reflecting surface is a part of the sphere. So let us say that this is a sphere which has a center, and this is a reflecting surface. So spherical mirror will basically be a part of it. So let us say this will be a spherical mirror, and yeah, so this is going to be a spherical mirror which will reflect light. And so let us move on to the terms that are related to it. So now let me just take this portion, to our next slide. Aha. So now we have a reflecting surface. Alright. So a spherical mirror is the mirror whose reflecting surface is of two types. Reflecting surfaces are of two types, okay? So the one that is bulged outwards, this one, inwards, bulged inwards, which is this one. So this one is basically called concave. This one is called convex. Alright, so again, a spherical, the focal length. So let us learn the terms associated with spherical mirrors first. So basically, the center of the sphere of which the mirror is a part is called the center of curvature. So this is called the center of curvature, and the distance between the two edges is called the aperture. Aperture, I must say, aperture. Or okay, I could be a little more neat if you want. Aperture. This is called the center of curvature. So okay, now what is the focal length of a mirror? When light rays fall on a surface, on this curved surface, they reflect. Okay, so let us say there are two or more, I must say two or more light rays are incident on the surface, they intersect at a point, and that point, all of them intersect at a point actually. So let's say there are a lot of them, and they intersect at this particular point, which I highlight in yellow. So that point is the focus of the mirror. Okay, so this point is called the focus, and the focal length is basically the length between that point and the mirror. So the thing in yellow you see is the focal length of the mirror. Alright, and the plane in which these rays lie is called the focal plane. Alright, so always remember that focal length is represented by f. The radius of curvature, which starts from C to the surface, is called r, and the focal length is always r by 2. Okay, so we are now familiar with what that is. Now in the second part we are going to learn rules of reflection. Thanks for watching, and do watch the second part.